Hello guys, I am Vaishali Kikan from Dopamine and we are discussing digital circuits. Today in this video, we are going to discuss 8421 BCD to access 3 code conversion. It's a specific type of code conversion. I hope you have watched all of the previous videos. You know at least what is 8421 BCD code, what is access 3 code. So if you still don't know about these two things, go and watch the previous video on these two codes and then come to this video. We have already discussed about the code converters also, which you can watch from the previous video. So these three videos are really important. Further, the video on K-map is also important. If you don't know how to draw the K-map, so go and watch the K-map simplification video as well. So now let's proceed with this type of code conversion here. First of all, we'll be discussing about the procedure for designing of any code converter. So first of all, you have to make a truth table showing the relationship between the input code and the output code. So here in this case, input code is 8421 BCD code and the output code is access3 code. Step 2 is for each output bit, you have to draw the equivalent simplified K-map. You have to determine the simplified Boolean expression using the K-map. So you will use the K-map for each output bit. Using the input bit, you will design the simplified Boolean expression. And then the final step, you will realize practically the code converter using the basic logic gates, AND gate, NOT gate, OR gate, right? So we will start our discussion with the first step where we have the input code to be BCD code, which is a 4-bit code D3, D2, D1, D0, right? So the BCD code varies from 0 up to 9. So here the input code is for 0, the representation is 0000. For 1 it is 0001, for 2 it is 0010, for 3 0011, 4 0100, 5 is represented as 0101, 6 as 0110, 7 as 0111, 8 as 1000, 9 as 1001, right? For then 10 you require more than 4 input bits, so you just need to convert the input of 4 bits to the output access3. So we will have the input from 0 to 9 only. So we will take the input from 0 to 9 because for 10 we require 5 input bits, which is not the case in this particular scenario. We require the conversion of 4-bit 8421 BCD to access3. Now the access3 is represented as E3, E2, E1, E0, and access3 is got using addition of the number 3 and then representing the specific number in the 0, 1 domain. So now here you can see 0000 is the representation of 0 for the BCD code. Then access3 is 0 plus 3, which is 0011. 1 is represented as 0001, which is represented as the number 4, which is represented as like 1 plus 3 is 4 for the access3. So for 1 we require 1 plus 3, which is 4, so which is represented as 0100. 2 is represented as 2 plus 3, which is 5, so 0101. 3 as 6, 0110, and so on up to 9, which is represented as 1100. So this is the input output relationship or the truth table for every possible 4-bit input 8421 BCD to access3 code. So now we have to make the K-map for the each of the output E0, E1, E2, E3 using the input bits D0, D1, D2, D3. So for E3, you are going to take the input bits from here and then you are going to draw the K-map. So now here we have to represent D0, D1, D2, D3. So 4 bits are represented using the 16 cell K-map. Here D1 and D0 is represented as 0001, 1011, and D3 and D2 as 0001, 1110. Right. Now we have to put the values of equivalent E3. So E3 is 0, 0, 0, 0, 0, then 1, 1, 1, 1, 1, 5 zeros and 5 ones. So we'll put first 0, 0, 0, 0, 0, then 1, 1, 1, right, 1, 1, then 1, 1 and 1. And then we don't have any input combination or output combination. So for that we will write X. X means the don't care. I hope you remember what is don't care. So now you can see the K-map is looking like this, right? So now it is the time for the simplification of the K-map. So here you can see this is an octet which is made, right? For the simplification, it is representing D3. Then you have two quads like this. So this is representing D2 D0 plus D2 D1. So this is the simplified expression for E3 D3 plus D2 D0 plus D1. Then for the next E2, you have 0, 1, 1, 1, 1, then 000, 1. So you'll put all of the consecutive values in the K map for the corresponding D0, D1, D2, D3. In this K map you can fill, and the rest of the digits or the cells which are not mapped, you can put a don't care there. So cross are placed there. So now we have to do the pairing. Now here you can check where all we can do the pairing. So here this is a pair only. So it is represented as D2, D1 bar, D0 bar. Then here you can check we are making a quad, right? And then we are making a quad here also, which is D2 bar D0 plus D2 bar D1. So simplified expression for E2 is D2 D1 bar D0 bar plus D2 bar D0 plus D2 bar D1. Now same we are going to do for E1. We are going to put these values corresponding to the D0, D1, D2, D3 values. So it is 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. So we are going to put here 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 0. So then all of the digits, all of the cells we are going to fill with the don't care. So now again making the pairing. So here you can see we are having a quad. Then here you can see we are again having a quad. So this is how you are getting D1 bar D0 bar plus D1 D0. So here this is representing D1 X0 D0. Now same you are going to do for E0 also. So here you can check the bits. You are going to fill in this K map. Rest of the bits you are going, rest of the cells you are going to fill with the don't care. So you can see here you are going to make an octet here. So like this and this. So this is an octet. So E0 is D0 bar. So this is how you simplified for all of the 4 bits. So E0 was equal to D0 bar. So we took D0 with the AND gate, we got D0 bar. With D1 with the AND gate, we got D1 bar. D2 and D2 bar, D3 and D3 bar. Right, so this is how we got all of the inputs, right? All of the input combination from the input 8421 binary code, BCD code. So from the 8421 BCD code, we have to make the access 3. So E0 was equal to D0 bar. So directly we connected D0 bar. Then E1 was D1 XNOR D0. So we took D1, we made this logic gate XNOR, and we found out it as E1. So if you have to make this using AND OR gate, so you can make using AND OR gate also. You will take D1 bar, D0 bar, D1 and D0, and then you can D1 bar and D0 bar are connected to AND gates. D1 and D0 are again connected to AND gates, and both of the outputs are connected to OR gates. So this is how, if you don't have to use XNOR, you can use the AND OR gate also. Then you have E2. Right, so in E2 you have D2 D1 bar D0 bar and D2 bar D0 plus D1. So this D0 plus D1 is used here also in E3 also. So D0 plus D1 we have taken and we are using it in E2 as well as in E3. So this OR gate we are taken. So it is, you can check, it is D0 plus D1. So this D0 plus D1 is going here and it is connecting with D2. So you can check here, it is multiplied with D2 for E3, right? And it is connected with D2 bar. It is multiplied with D2 for E3 and multiplied with D2 bar for E2. Then for E2 we require further more terms, D2 D1 bar D0 bar. So we took D2 D1 bar D0 bar. So we took the AND gate and we sent them to the OR gate. So this is how we got the E2. Similarly for E3 we require addition of D3 with it. So we just took D3 and we put it to the OR gate. So this is how we got E0, E1, E2 and E3. So I hope all of this is clear. If you face any difficulty or you have any doubt, you can put the doubt in the comment section. And you can meet me soon in the next class where we'll be going to discuss the next type of code converter. See you soon. Till then, bye-bye. Take care. Thank you.